Okay, good morning. Welcome to the second lecture for the machine learning for data science. So today we will look into the concept of binary and multi-class classification. So this is one of the type of machine learning that we will use when we want to learn our data. So last week we discussed about the an overview of machine learning, uh, what we can do or perform using the machine learning in learning our data. Kan? So, do you have any specific question that you want to ask me? No. Okay. So, all the video, the recorded video, will be uploaded at the Smart Tree. If you missed the lecture last week, you can always refer back to the video. Okay. So for this week, we will look into this concept. Okay. Before we proceed, looking into the binary and multi-class classification, we refer back to the type of machine learning that we can have when learning our data. So there are three types of machine learning. The first one is called supervised. The second one is called unsupervised, and the third one is called reinforced learning. So for this session today, we will look into the supervised learning, which can be categorized into regression and classification. Okay? So they are called regression and classification because they are dealing with different type of data that you want to learn. Okay, so for example, we use the regression technique to predict the target values of continuous variables, meaning that if you want to predict numerical values or continuous values, then regression is the best technique that they can use. In contrast, we use the classification technique for predicting the class level for for given input data. So this is when we want to predict a class membership. If you have label like bi or not bi, male or female, um, pass or not pass, so that is what we consider as class label. Okay, so we call it classification. Okay, so in classification, before we can use the model, we have to test. No, we have to train them. So we design the classifier model, then we train the model using input train data. So our data will be divided into train data and also testing data. Okay. So every time when we want to do an experiment for the classification, most of the classifier require you to have training and testing data. Okay. So in this course, most of the practical, when you perform classification, you have to divide the your raw data into training and testing data first before you can proceed with the training phase. Okay. Okay. Um, when we learn, when we want to learn a class from example, given a list of samples or example, we want to learn why we why that particular sample is assigned to class A or B or C. Okay, so for instance, if we have class C of a family car, so we say that um, a family car we label as class C. So when it comes to the prediction task, we want to ask whether the car X family car or not. So yes or no lah. Okay. So what do people expect from a family car? So we need to have a list of features or list of indicator that we can use to classify the car X as a family car. And the output would be positive and negative, meaning that um, we are saying that they belong to family car, positive, and not a family car as negative. Yeah. So the input that we could use, for example, we could use price or the engine power or number of seaters or many more. Okay. So for this example, let's use price and engine power. So we use these two attributes or two features in order to learn the data. Okay. So in this question again, let me go back here. Okay. So the question is here: is car X a family car? So the example is yes and no. Okay? So since we have only two labels, so we call it binary classification. Okay. So if we have more than two, then we call it multi-class classification. Okay. Okay. In this graph, we have a 2D layout of the sample that we have. So let's suppose we have a training set. Now we are trying to try to learn the class based on the example that we have here. Okay. So we have 5 positive and we have around 10 negative. So we lay out the position of each of the sample based on the engine power and also the price. So for each sample that we have, they for each sample they are represented by the x1 and x2, where x1 is the price lah, and x2 is the engine power. Okay, so for all the sample that we have, so this is all the sample that we have. This is x sample. Okay, so this is all the sample that we have. We have up to n. So n is number of samples. So in this case, we have 15 lah, because we have 15 sample, 10 negative and 5 positive. So for the training set that we have up to 1 to 15 sample together with the label. So R is the label. Okay. So R is the label. They are 1 if X is positive, meaning that they are a family car. 0 if they are um, not a family car. Okay. Any questions so far? If you're okay, can you type number 1? Okay. Okay, if we highlight the area that we want to focus, is this area, kan? So this is the area that we want to focus. Okay. So when it comes to the classification, we want to find the range of price and the price of engine power, or the range value for the engine power, so that we can estimate the area that we can consider as positive area. Okay, so over here we are saying that as long as the price is greater or equal to P and less than P1 and less than or equal to P2, which is this range, and then as long as the engine power is greater or equal to E1 and less than or equal to E2, which is this range, then we consider them as positive. Okay, but this is the um, we could say this is the ideal scenario. But when we train the model, maybe they draw different rectangular, for example, like this, okay? Or they write here. So this is what we call hypothesis. Hypothesis in machine learning, meaning that that area is considered as area that can be considered as positive. Okay. So when it comes to hypothesis class H, the yellow one is the one derived by the model. Okay. Um, if we compare with what we have assigned before this, which is the blue one, so there are some overlapping and some non-overlapping. Okay. If we look at the graph here, so the overlapping is inside these boxes. So as long as they fall inside this, then your hypothesis and the actual one match. Okay, but outside that, okay, based on the hypothesis, it says that uh, if if X is within that yellow box, um, the class will be one if H say X is positive. Okay, outside the box is 0 if the hypothesis say X is negative. Okay, but the problem is we may have some error here because over here the hypothesis say they are positive, kan? Because they are still in the yellow box. Okay, so this is positive, but actually if we compare with the blue one, they are not positive, they are negative. So that's why they call it false positive. They are positive, they are considered as positive by based on the hypothesis, but they are not positive. So this is false positive. Okay, similar to the area at this side, um, if they fall outside here, they are called negative, kan? But if you compare with the blue box, they are actually positive. So this is if we use the hypothesis, it says that this is negative. So that means this is false negative. Okay. So the error that we can conclude from this scenario is that we will look at the number of item which the hypothesis say the class which is not the same with the actual class that they have here. Okay, so they just accumulate the number of sample which does not match the class label. So meaning that the error that we have here, given the sample that we have for all the 15 sample, we compute the probability of the no we, we we compute the number of error that we have that does not match between the hypothesized one and also the actual one. Okay? So the idea here is that we want to have the yellow box to match as close as the blue box. Okay? So let's suppose this is the blue box. Okay, so um, we could also have the most general hypothesis in which we expand the box as much as possible to outside. So this one we only cover the smallest area, and this is cover the largest area here. Okay, so this is G. This is very specific, and then we also have the middle one. So what we wanted to do is we want to shift this box in order to have similar ano lah, um, we need to get this center no this edge to the center of this specific and general, so that the probability of having the item to be inside here and inside here will be 50-50. Okay, so this is the specific one, this is the general one. So we choose edge with the largest margin. So the largest margin meaning that these are the same, okay? The largest margin. Okay, so your hypothesis will be here. So that's how we set the hypothesis of the model, and that's what we call we have trained the model and we have optimized the hypothesis area of the classifier. Okay, but when you perform the classification, you will not see this one. This is just to give you an idea how the uh, what happened during the training session. During the training session, basically they want to optimize the boxes that they have between the specific and two general boxes. So they make an hypothesis box that will cover most of the sample in your dataset. Okay. Any question? No? If you okay, can you type number 2? Okay. So um, for binary classification, normally this is used for two class label, huh? But in most cases, we also have multi-label. So we have to use multi-class classification. But for those who, when you want to perform machine learning in order to learn from your data, you have to look at your data set, how many label you have. Okay, um, and also the feature that you want to predict, whether they are numerical values or categorical values. So if in numerical values or continuous values, you have to use regression. But if you are trying to model the categorical values, you have to use classification. So these are some of the algorithm which are designed for binary classification. Okay, so we have support vector machine, k nearest neighbor, decision tree, naive Bayes, perceptron, logistic regression, and many more. We will cover all of these. Okay? They cannot be used for multi-class classification tasks, at least not directly. Meaning that your your if you use this algorithm for multi-class classification, you will not get the best result. So make sure that you understand your data set first be- before you can suggest before you can suggest which algorithm that you want to use. Okay. Okay. Now let's take a look at the multi-class classification. So what are the differences between binary classification and multi-class classification? Um, the binary classification, only two instances are present and require only one classifier model. So we only need a model that will be able to draw this line to separate the two set of classes. However, if you have multi-class classification, we have more than two classes. So basically, we need three model here. One to draw this line, one to draw this line, and one to draw this line. Okay. So for multi-class classification, we have multiple class label, and the number of classifier models depends on the classification technique we are applying to. Okay, so it depends on the technique of classification that we use. We will look into that one later on. Okay. So basically, what is multi-class classification? The input can belong to one of the K classes. Okay. So given one input, we can classify them as one of the K classes that already predefined. So the training data input associated with class label a number from 1 to K. Okay, so we have K labels. So the prediction task here is given a new input, we want to predict the class label. So the class label coming from class level 1 up to K. So each input belong to exactly one class, not more, not less. Okay. Otherwise, the problem is not multi-class classification. Um, if they belong to more than one class, they are called multi-label classification. Okay, so yeah, this is the multi-label classification. If an input can be assigned to multiple classes, so it is called multi-label classification. Okay, so example of application. For example, we want to perform handwritten recognition because we have 26 alphabet. So we have 26 classes. We have input, a photograph of an object. So we want to classify them as one of the type here, car tire, truck, laptop, and so on. So thi- this is the example application for images. This is for the language. If you're taking natural language processing or if you're taking information retrieval, so the input here is a news article. So the output, which the output would be which section of the newspaper should it belong to. So sports, politics, economy, business, leisure, and many more. So that is based on predefined classes that we have. For the email also, we could also assign them to different classes depending on the content of the email. So we could create a few folder that represent the topic of the email that you have. Okay. Also, we could have an audio command given to a car, and then the output, which which of a set of action should be executed. So this is the speech-based instruction-based, in which you um, say the word that you want to do, and then the system will classify which action should be taken in based on the classification of your audio command. Okay, so this is a very interesting task here. For example, you want to design an audio command that will switch on the light, switch on the fan, switch on the TV, uh, off the fridge, and so on. So based on the speech, uh, you convert the audio into text, and then the text will be categorized as one of the set of action that should be executed. Okay, so based on our knowledge in binary classification, can we use binary classifier to perform the multi-class? Okay, can we use a binary classifier to construct a multi-class classifier? Yes, we can. So what we can do is we can decompose the prediction into multiple binary decision. So how to decompose? So, let me, so this one is supposed to be one versus one. Okay. Okay, let's take a look at the this is the scenario that we have if we have multiple classes. So for this multiple classes, we have training data. So this is our training data. And then in this case, we have how many? We have we have 7 here, we have 8 here, and then we have 6. So together our n is 21 lah. So in our training set, we have 21 samples, and each sample here is represented by the price and also the engine power, and then each one of them will have their own label. Okay? So for this one, we are saying that that sample belong to that class. We have I here, so meaning that we have more than 2 classes here, 1, 2, 3. So we are saying that that particular sample belong to that class if um, that sample belong to that particular class. 0 if that particular sample is belong to another class, and the class is not the same with the one checked first here. Okay? So for your trend hypothesis, so we have also a few classes here. So hypothesis for 1 up to k. Okay? And based on the hypothesis, because we're supposed to have, based on this example, the hypothesis is up to 3. Okay, so the hypothesis area for this one could be this, okay, which is different from the yellow one. the hypothesis for this one could be this, and then the hypothesis for this one could be larger. Okay, so based on the hypothesis area that we have and also the actual area that we could have, we may generate a false positive and false negative. Okay, so let's suppose we have this. We want to look at the one versus all. So, so what we want to do is, um, here we have three classes. Okay, so what we want to do is we build the first classifier. This is your first classifier. So meaning that we are focusing on this triangle, and the rest will be considered as the other class. Okay, and then the second classifier. Okay, we will look into this square, and the rest we consider as the second class. So we look at the diagram, we know that this is binary classification, but in here we are looking for the green triangle classifier, and the second one is rectangular blue classifier, and last one is the, the X red classifier. Okay, so for this we need to create three classifier for the three respective classes. Okay. So how do we perform this one in the actual data set? So we will we will have three classifier. So based on the number of class that we have here. Okay, so how do we change the data? So for the green data set, so for the green data set, we consider as this one as positive. So the rest of them we will change to negative. Okay, so the rest of them we change to negative. So which means that for this one we only have two values, two distinct values. So positive plus and negative, no, positive one, and also we have negative one. So similar to um, training data set for the blue one. So for the blue one, we will have the positive here, and then the red one is this one. And then we feed into the classifier. So this is the class one is what just now? Green, blue, red. So the green is here, the blue, and then the red is the third one. Okay. So in our example, the class is only up to three. Okay. So this function will be computed based on the input that we have. So the the higher the value that they have here, for example, if this is zero point 0.9, uh, this is zero point 0.4, and no, this is we have a positive zero point 0.9 weight, and then this is positive zero point 0.4, and then this is negative. So over here we are looking at the max value of the argument, so which is this one. So we will label this one as positive. Okay, so this is how we visualize them. Okay, so we have three set of them. Then we have a classifier for the blue one, and we also have the classifier for the red one, and also the green one. Okay, okay, how do we interpret this one? Um, like I mentioned just now, once we pass the test data to the classifier, we got an outcome in the form of positive rating derived from the green classifier with probability of 0.9. Again, we have a positive rating for the blue class, but with lower probability score. Okay, and also we have a negative classification score from the remaining rate. So the answer will be positive, and it will be classified as green. Okay. But the problem is when we combine them, the black point here are not separable with a single binary classifier. So if we combine this is the scenario in which we are not able to solve this one. Okay. So this is the issue you can investigate, and many people have also proposed a few solutions on how to um, improve this classifier. So that's why when you perform or when you're using different type of classifier for multi-class classification, you will have different performance accuracy because some of them cannot cover the black dot here. Okay. So any question? If you okay, can you type number 3? You okay? The last one, the last part is 1 versus 1 lah. Okay, 1 versus 1. In a 1 versus 1 classification for n class, so this is number of classes. Huh? This is number of classes we have. We must generate n times n minus 2 divided by 2. No, minus 1 divided by 2. So for example, if we have 3 class, so that means we have 3 times 2 divided by 2. So we have 3 classifier lah. Yang macam tadi tu. So we have 3 class kan. So we need to have 3 classifier. Okay. So using this classification approach, we split the primary dataset into one dataset for each class opposite to every other class. So for example, if we have 3 here, okay, so we will split them into 3. So if we, for example, each binary classifier predicts one class label when we input the test data to the classifier. Then the model with the majority count is included as a result. So for example, they are called 1-to-1 because we are saying that we will only include one class versus one class. Yang tadi tu, when we compare to this is one class versus many classes here kan. 2 or 3 classes here lah. So this is what we call one versus all. Compared to this is 1-to-1, meaning that I only take, first I will only take this, then I will build the classifier. The second one, I will take this, and I will build the classifier here. And then last one will be this, and I will build the classifier here. So similar to the previous one, but this one, we only talking about one class versus one class. Okay. Okay. Many algorithms used for binary classification can be used for multi-class classification. For example, we have k-nearest neighbor, decision tree, naive Bayes, random forest, and gradient boosting. Okay, so look at your data set first. How many classes you have? Then you can decide to use this algorithm in order to learn your data. Okay. Okay. In conclusion, um, if you look at the work behind the binary classification and also multi-class classification, a lot of work has been done behind the scene. But when you apply the algorithm directly to your data set, you what you will get is only the accuracy or the class level, but you do not know what happened behind. Yeah? So they also have listed what algorithm can be used best for binary classification compared to multi-class classification. Um, it depends on the number of class that we have. We need to create many classifier model and to train those model using those input training data set that we have um, obtained. Okay. So in one versus one multi-class classification, we split the primary dataset into one binary classification dataset for each pair of classes. So compared to one to many, one versus many, um, we split the primary data into um, one to many classes that we have. Okay. So in the next session, we will look into some of the classifier that we can use in order to perform the classification. So until then, that's it. Okay. So by now you should be able to understand the concept of binary and multi-class classification. Um, in our next session, we will go through some of the practical exercise. At the same time, we also learn the theory behind the algorithm on how they perform the classification. So um, that's it for this session.